Here we have an object of mass m is equal to 8.5 kilogram supported by a cord like that on an inclined slope. The inclination of the slope theta is 30 degree. So we need to find few things. First, the tension in the cord. What is the tension in this cord? Then the normal force acting on the block. What is the normal force like that on the block? And then finally, if the cord is cut, find the magnitude of acceleration on the block. What will be the acceleration of the magnitude of the acceleration if this cord is cut? So this is mass, and it is m is the mass, and its weight is acting in this direction like that. So we have to find, this is the direction of g or mg. So this one is 90 degree minus theta like that, this angle. And if we talk about the normal force, which is like that, that will be, what is that, we need to find out. So this one is mg. So what is the component of mg in this direction, and what is the component of mg in its perpendicular direction, that is this direction? These two things we need to find. So we can figure that out by looking at the angle here. Let me use a different color, so maybe red. So this angle is 90 degree, and this small angle I drew it before, this one is 90 minus theta, because this triangle is right, this is a right triangle and this is theta. So of course this angle will be, this is 90 degree, so this angle will be 90 minus theta. So this particular angle which we are interested will be theta, because 90 minus 90 minus theta like that. So it's becoming 90 getting cancelled, and this minus theta is becoming plus, so this is theta. So this angle is theta, which means this component will be mg. This is a very important thing, we need to remember that. So this will be theta, mg cos theta, component of weight force, and the reaction force will be of course also mg cos theta, and the force in this direction will be mg sin theta, because that will be just the perpendicular of this one. These components, this part, these forces, this component is mg cos theta and this component is mg sin theta. It is already very clumsy, but I hope this is understandable. So the tension in the cord will, of course, will have to compensate this force mg sin theta, because that is the force in this direction, and that is mg sin theta. So part A will be, the tension in the cord will counteract this one, because the cord is supporting this force, it is cancelling this force, and that way the object is steady there, it's stuck there, it's not falling, or it's not going upwards either, and it's not going downwards, so it's just staying there in a stable situation. So mg sin theta, that will be m 8.5 times 9.8 and sine 30 degree. So this one equals to 41.65 Newton, I guess, approximately, or approximately let's say 42 Newton. So that's there. Then we need to find the normal force acting on the block, which is of course mg cos theta. We just saw the component of, because that is the reaction force of the surface. So basically I will just draw an analogy. When an object is like that on a horizontal surface, then the weight force is mg and the reaction of the surface is mg cos mg, just mg, sorry. But when it's like that on an inclined slope, the weight is still like that, perpendicular, but in this direction, perpendicular to the surface, because this is inclined, we just saw that this is mg cos theta. So the reaction force, the normal reaction force, is also mg cos theta. So that will be here Part B is mg cos theta reaction force, and that will be 8.5 times 9.8 times cos 30 degree. It's not readable. Anyway, this is cos 30 degree. So this is becoming 72, I guess, approximately 72 newtons. So that's there. Finally, the final part is, if the cord is cut, what is the magnitude of the acceleration on the block? So if the cord is cut here, it will start going down, and the acceleration will of course be g sine theta, just this part, g sine theta. So acceleration c will be g sine theta. So that will be 9.8 sine 30 degree, which is 4.9 meter per second square.